All right. Hey, everyone. Welcome to this is the first of the series. We're just going to be looking at different oracles, really just kind of getting into them and actually seeing how they work. Hopefully going through some code, maybe seeing an example and some solidity. We'll see how far we get. So it'll be good. But today I have Adan from Witnet. Um,
Hi. Thanks
yeah,
for having me.
he's here. Yeah, I guess before we, jump into the code or whiteboarding it, like, do you want to give us like a brief history of Witnet? Like how did you kind of get into it and where was, because like you guys have been around, I think, you guys have been around slightly longer than Teller, which is rare. So yeah.
Yeah, it's been quite a long adventure. Yeah, Witnet actually started as a spin-off of a previous project that we started in 2014 called Stampery. We developed this technology that allowed us to do blockchain timestamping at scale. So essentially to notarize digital documents yeah, using public blockchains, Bitcoin in the beginning, and then from 2016 also Ethereum. So, well, actually Ethereum Classic because that was the original chain before the fork. And and from the early days we had this view of using this technology to replace trust in third parties, to remove those single point of failures, and so on. And we started tackling this notarization use case, just because we wondered, how do you bring certainty to this digital world in which there are terabytes or petabytes of video being uploaded every hour to YouTube, and so on? How do you have the equivalent of a notary public, which is what gives you certainty on the content and the existence of documents in the physical world? How do you bring that to the digital world? Obviously, it needs to be something that there's no human intervention or anything. So we started to work with this concept, and over the years that we were working in Stampery, we realized that our customers, beyond wanting to notarize data sets or digital files or whatever,
What
they
was like what were the first things you were notarizing like back then?
uh, at first it was deeds, patents, things
Oh,
like that. Yeah, but then there was also, let's say, a case for um, artwork, whatever, like to copyright protection and so on. So the people started more and more asking for some way to notarize websites, so as to prove that the content of some website was this in a specific point in time, like let's say um, the service agreement of some website or whatever. Yeah, I don't know, those business use cases. And at the same time we started working on Ethereum and so on, and we started realize that both the Oracle problem on how to bring data without trusting the data relayer, let's say, or trusting the messenger onto a smart contract, and this other thing about notarizing websites was a very similar problem, and that maybe both could be solved at once, because essentially the problem is exactly that. How do I prove to other people that some data is like it is, and that's what the server is serving in a point in time? And how do I consume that data without giving the data relayer the power to tamper with the data? And we started working on that concept in the summer of 2017, and we ended up publishing this white paper in November 2017, in which we described roughly what Witnet is today. So it's a mechanism for attestation and delivery of data, which essentially in the blockchain world you would call an oracle, and this one that has very particular properties and characteristics because of both its architecture and the fact that its security is based on the very same principles of most blockchains today, which you could call crypto incentives, crypto economic design, whatever. So at the end of the day, it's an oracle that we like to call crowd attestation mechanism. So the idea is very similar to this idea of Schelling points or focal points, as pioneered by Thomas Schelling. And the idea is that if you without if you have in our case is very simple. You have a broad network of independently operated nodes, which we call witnesses. And when you have a query for the oracle, what you have is in this query is a little piece, a little script that says, hey, go to this API and fetch this piece of data, and this go to this other API and fetch this other piece of data. And then you need to aggregate together these pieces in this particular way. Like, for example, you can query the price of Bitcoin from 5 different exchanges, and then remove the outliers and aggregate and compute the average, for example. And that will be executed by a number of nodes from the network, a number of witnesses, a number that you can decide. And but you cannot handpick which are the reporters. Let's say you cannot handpick which will be the
Yeah,
witnesses.
we're
Those
gonna get
are
into the design. That'll be,
exactly
I want to.
those are chosen randomly and secretly. So they compute their eligibility. Let's say I can elaborate on that
And
maybe
well, I
later.
mean, how's
And
yeah. No, I mean, you can finish if you want.
oh yeah, and then what happens is that if those reporters, which let's say report that data through a commitment and reveal a scheme, if they agree with a majority of reporters that participated in resolving that query, they will get a reward as deposited by the requester. They will get some stake back that they need to use as collateral when they participate in resolving that query. And they will get some reputation points, which is a special thing.
Cool.
And then if they are not with the majority, they lose their stake, they don't get any reward, and they lose half of their reputation points. And these reputation points essentially allow them to have more eligibility in the future, so as to have, let's say, a midterm or long-term incentive for those nodes to.
Well, I still have a lot of questions. We're gonna get into it. I mean, how was I guess going back to the beginning? You know, like
Yeah.
we'll start early. You know, did you guys raise? Like, what was that like? You know, because this was.
Oh.
Did you catch it before the 2018 crash?
So I think it was in first quarter, second quarter of 2018 that we ran this private pre-sale of the with coin.
You guys did like pre-sale
Yeah.
of WIT tokens.
Yeah, through the SAFT, the
Okay.
simple agreement for future tokens. So essentially, we sold the right to receive an amount of tokens in exchange for cash.
Nice. Was that like VCs or just people you knew? Or
So most of the money came from former investors of Stampery, which
oh
had
yeah,
a very
Stanford had.
healthy network of investors. You have blockchain capital there. You have Boost VC. You have Draper and Associates, and then we also were very lucky to onboard some other funds that were not that big at that time, but have grown a lot ever since, like 1KX. You have Economy. You have Coin Fund. We have also Arlington XRP on board. So we are very, very happy with the names that are backing us and with all the value that they have provided beyond the funds.
Cool. No, I mean, I always love because, like, you know, I have to ask because, like, raising back in 2017, you know, that was like I was there too. Like, I feel like people would do it completely differently nowadays, you know.
Yeah, most probably. I don't know. I think the way we went was quite unusual at the time, because in 2017 everyone was doing these crazy ICOs, just
Yep.
publishing some smart contract. You throw some ether at it, and it will give you the token right away. and we thought that that would be dangerous for us as a US
Legally,
company.
you guys are
Not,
US
not
company?
we are a US company, yeah.
Oh, cool.
As of today, Witness Foundation is a foundation based in Delaware, and it's a non-profit, non-stock corporation. So which is a, let's say, a legal framework that works very well for us, both because
How
we
many,
have
how many, how much of your team is from the US, I guess, or because you're not from the US, right?
I'm not from the US. I'm from Spain. Right now, it's two people from the US.
Okay. Well, I feel like everybody does the opposite. Nobody actually tries to make a US company. You always try to make
Yeah,
money.
that's funny. That's funny. But in our experience with the Stampery and so on, US is a very business friendly country, even for foreigners as ourselves, and we were obsessed with this security law issue.
Yeah.
Then, as we were planning the fundraising, the DAO hack report from the SEC came out, and we had to rethink and to reconsider a lot of stuff. But still, we considered that it didn't make any sense to run away from from that, and that there needed to be some way to do it perfect in a perfectly legal way, and to replicate what others had done right. That's
Yeah,
the
because
case
I
of
mean, EOS, which was
licensing.
launched a little bit before that, was like, they minted the ERC-20, even though they were going to move to their own blockchain
Yeah,
eventually.
that was our
Yeah.
main, like, the thing that we had the clearest at that point, that we couldn't mint the token.
Yep.
Like, the token would only exist once the network was fully functional and it was open, permissionless, and decentralized. Only then the token would exist, and that's exactly what we made. So the downside to that is obviously that we were not exposed to the market until, you would say, October 2020, which is when we released our mainnet. But it's even worse, because from there to being listed in some good exchange, it took even 1 year more. So we have been exposed to the market only for the last half a year, and that's not been very good for the market. uh,
Yeah. No, I know. It's always like that. Like, you guys could have been launched like pre 2018 crash. It's like absurd. But anyway, super cool. And yeah, so before we get started, any giant changes since before, so I'll whiteboard it out here in a sec. Any giant changes from the initial white paper to where it is now? Like, what was it?
um,
Any big misconceptions you had going in?
So that's a good one. I think one big thing is that in the beginning, like in the white paper, we were talking about the Oracle capabilities being powered by a headless browser. So essentially, that you could use it as as a scraper, that you could read data from any website. And obviously, that won't work, because it's while APIs have an incentive to be consistent in the way they present the information, and in the way that they present data in a structured manner in JSON or XML or whatever, that's not the case for websites. So if you try to get data from websites from one day to another, they can change anything in the HTML, and your data request, your query will break. And then
Yeah.
if you are relying on that for your smart contract, you would you are wrecked. And if that can happen, then probably you need to introduce a mechanism for updating the request, and then you have another point of failure in there. So probably not the best idea. And so that's the biggest difference, probably. And the biggest improvement from what we had in the white paper is that in the white paper we didn't have explicit manner to stake, let's say. So the anyone could participate in a data request without risking their existing funds. They would only risk their future funds or their expectation of mining. And obviously that's not enough for protecting the kind of DeFi use cases, for example, that we see today. If we are trying to secure multi-million or multi-hundred million TVL, the incentives are there for for messing with the Oracle. So you need to make sure that the Oracle itself allows for collateralizing the queries with amounts that make sense for the value that is being protected. Otherwise, there's a huge incentive to let's say to do a bravery attack on the witnesses, on the reporters, and so on. We have a couple of articles elaborating on that that are quite interesting, and it's
Yeah.
something that was even explored theoretically before these kind of oracles existed. There's one article from the Vitalik Buterin blog in which he describes a system that somehow resembles what Witnet is today. He called it Shelling Coin, and he tries to explore how a bravery attack would work on that and the different kinds of attack. There's this P plus epsilon attack. There's a lot of stuff going on in there that we had to study very carefully and to come up with solid solutions.
Yeah, well, I mean, like Augur originally had a lot of the same sort of mechanisms, and I think they had. But anyway, okay. So now that we're half hour in or 20 minutes in, let's actually start whiteboarding it out. I think this will be fun because I want to actually see how Witnet works today, and I'm going to try and draw it out, and then you can sort of let me know where I'm wrong, if that works.
This is going to be fun.
Yeah. So like I think the first thing that's different about Witnet than a lot of other oracles. So like we'll draw over here, like this will be like Ethereum or some EVM chain that is the users. And then you guys are not actually, I mean, you have a smart contract over there, but your main chain, you guys are a separate blockchain completely, right? And
Yeah,
then
exactly.
do you use any architecture? Like, is it a Cosmos chain? Or is it just a completely
So when we started to design it and to build it, the issue back then is that neither Tendermint or Substrate was mature or flexible enough for our use case. So sadly, we had to build it from scratch. It's something that I will never brag about or feel proud of because
You should brag
ideally
a little
there
bit.
should have been a framework for that, which probably you could do today with Substrate or anything like that. But there was nothing like that back at the day, and we had to build everything from scratch. And the decision for making our own chain was mainly driven by this view that in the future there could be multiple different chains with different trade-offs in terms of latency, security, decentralization, whatever. And I think time has proven us right. And so we said, let's keep the Oracle, the main Oracle workflow in our own proto chain, let's say in a very simple chain that is nothing fancy as Ethereum or anything like that. It's more alike to Bitcoin. It's very, very, very silly, but
So
very
is it, can you do
straightforward
on
and
it?
tailored. Sorry?
Can you do smart contracts on it?
No. It's totally tailored to the Oracle use case. So
Okay.
there are value transfers transactions, like you can send Bitcoins from one user to another. But then the rest of types of transactions are focused on the workflow of resolving the queries and so on. So it's a very ad hoc thing.
Okay, cool. No, that was like, yeah, it's super. And then, okay, so, and now continuing
So
my,
then the process when you are a smart contract developer, you are developing on Ethereum or whatever chain, and you want to use Witnet as an oracle. So you essentially interact with a contract in your same chain that we often call the request board. And when you interact with this contract, you you send the query to that contract. You are explicit about the query, and the query, as I described before, lists all the data sources that will be used and how to retrieve, how to process that data, how to aggregate it, and so on. And then what happens is that there are bridge nodes that are nodes that can read the chain state of both Ethereum and Witnet, that will take the bytecode of that query, which is it's a bunch of bytes, and they will relay those that query to Witnet, to the Witnet chain. Then it gets resolved inside Witnet through this commit and reveal process and so on. And then there's a tally, and there's a final transaction that says, hey, the result of this query is this. And then the bridge nodes relay back that result to the originating chain, to the request board, from where the smart contract that requested the information can read it.
Okay, so let's back up a bit. So on there's the Witnet chain here. It seems like there's like two separate people in the Witnet chain. There's like, it seems like you have nodes and then validators or miners. What do you call them?
So
Or are they the same?
in general, they are the same. Yeah, the
Okay.
witnesses are the
So witnesses are
nodes
miners.
actually retrieving, aggregating the information are at the same time block proposers or validators, miners, as you want to call it.
So there's no like, is there a difference? Can you run like a Witnet node and not be a miner?
You can
can.
disable that module, but nobody does, as far as I know.
Okay. Well, you know, like in Bitcoin or Ethereum, you want
Exactly.
theoretically it's more about the number of nodes, not necessarily the number of validators, right?
Exactly.
So I don't.
As far as I know, only the public nodes that the Witness Foundation runs run without the mining part.
Okay. Okay, so you have these witnesses over here, and then this is where, I guess, how does the chain work? You know, so you get some, I guess, similar to like Ethereum, where people basically are broadcasting these transactions. With Witnet, the transactions are what they include, I guess, queries, correct?
Exactly. There's a type of transaction which is called data request, and it has the data sources and all the scripts for aggregating the information, everything in there.
And then so somebody will broadcast a transaction that says like, hey, and then similar to what you were saying, so you would say like, you would specify the exact APIs, right? That you want. So you would say like, so in a transaction down here, so you would have like api.coinbase.com, and then what's included, how to parse it as well, right?
Exactly.
So down .com, what do you have, like 0 price or something like that?
Something like that.
Yeah. And then, you know, Kraken, and then Binance, and then you would take like, what would you have in here? Like, I want the median of these,
for example.
And then you would have like median, and then these guys, this guy would come and he would say, hey, this is what I'm doing, and then here the answer is, you know, 20,000, for instance. This is the answer to this, and he would put that forward, and then your selection piece would then pick other random nodes, I guess, to also validate this, or how would that work?
So it's on the requester to decide how many nodes will be hired, let's say.
So this is the requester. Is the requester one of the other witnesses, or is it, this is completely separate, right?
Separate. So that's actually chosen on the Ethereum side, let's say. They say, I want this to be resolved by 100 witnesses. So the transaction itself has the 100 number in there, and it will only be considered resolved at the protocol level once you have the report from 100 nodes that prove their eligibility to participate in that and to have a say on the result.
Okay, so he'll say 100 witnesses, and then he'll push it over here, and then they'll get this request. I'm guessing, is there some sort of fee with that request they're willing to pay?
Yeah. So when you send a data request, there's there's a fee for taking block space
Okay,
when you publish the data request. That's
it's like a
obvious.
renting kind of thing, like ETH 2.0, where you get it, or do you get it forever?
Uh, that right now it's like in Bitcoin, let's say.
Okay,
Very straightforward model. There are proposals to change
okay,
it to something
cool.
more similar to what Ethereum is doing now. And but the nice thing is that the value transfer transactions and the data requests don't compete with each other for block space, because each block has like different buckets for different types of transactions, so that even if, for example, there's a lot of tokens being moved in and out from exchanges, for example, or from one account to another, that doesn't mess with the main use case of the network, which is processing the queries, the Oracle queries. So those have a reserved space for them, and that makes for up to 80% of the block space.
Okay. Okay, so they would get this, and then are these witnesses, are they staked witnesses, or is this proof of work?
So it's essential. It boils down to proof of stake. Yeah.
Proof of stake, okay. Yeah, because I read something.
The mechanism itself is actually, let's say, similar to what Algorand or Filecoin have. So it's powered by a verifiable random function, and then what you do is essentially they use that VRF uh, applied on the previous block to compute their a random number that only if it's lower than a threshold, they are eligible for participating in block proposing and so on.
Okay, how much is the stake, by the way?
So the thing is that they don't. There's no explicit staking for the mining itself, so it's rather probabilistic based on their reputation points and so on.
Well, so you
And
stake with though, right?
yeah, so the staking part goes with the data requests. It's on the data request side where you have to stake. So when you are eligible for participating in resolving a data request, you need to collateralize that participation. That, like, let's say, the commitment transaction in which you you participate in resolving, you need to collateralize that, and that's essentially a mechanism for civil attack prevention.
Or you would say, so
Uh,
this person would request, I want 100 witnesses. And then if
mhm.
you're a witness, you would say like, okay, I'm going to run this. And then I guess I have to put down 100 wit or something like that
For example,
with
uh-huh.
with this specific request that I lose if I lie, right?
Yeah.
And then 100 people have to do that.
Doesn't the requester have to specify how much
So
collateral?
I mean, does he also specify, in addition to the number of witnesses, the collateral amount?
Yes.
Okay, so 100 witnesses plus 100 wit or something like that each. Or I don't know what your denominations are.
with
Yeah, well, I mean, I don't know if 100 wit is that a normal amount? Like, what would be like?
yeah, perfectly normal. Yeah.
Do they usually like? I mean, how much is that? Would that be like a few bucks? Would that be, like, do people want like millions of dollars worth of stake on each one, or is it more like?
It really depends on what you are trying to
Okay.
secure. Yeah, ideally the total amount of value being collateralized should equal or outnumber, let's say, the value that you are trying to protect.
Okay.
Only ideally, yeah, of course.
Okay, and then so they basically have to have, so you would have to be having wit in order to answer, and then you get selected based on your reputation, right?
Exactly.
Selected, stake.
It's not a linear mechanism. Let's say it's not like if you have twice the reputation, you have twice the chances to mine a block.
Well, because obviously you have to start somewhere, right? F start at 0. So,
Exactly.
cool. And then is reputation transferable?
No, it's not. In the sense that you cannot make a transaction to send your reputation to a different identity, like for example, to farm reputation points and send all of that to a single identity. That you cannot do it. But what happens is that reputation, you earn it every time that you participate correctly in resolving a data request and resolving a query. You lose it if you don't, if you are not with the majority.
Okay.
And then the reputation expires.
How
So
fast does it expire?
so if you, for example, get 50 reputation points on block X, then on block X plus a fixed amount, you will lose it. So you can only
Okay, so it only goes through the
leverage.
selection process for the next few blocks or whatever, for the next.
Exactly.
Okay.
It will give you an advantage for a while, but then you cannot keep accumulating and accumulating and accumulating. It gets redistributed all the time, and the amount of reputation points that there are in the system in total, it's a fixed amount.
But so I'm guessing like you could theoretically sell them like selling your private key kind of thing.
Exactly.
Yeah.
Yeah,
So
that you can do.
this would be like the attack vector, I'm guessing, right? Like somebody farms a bunch and then goes and sells it. Well, you know, because like
Yeah,
that.
that would be like an exit scam, let's say.
Yep.
The problem with that, of course, is that when you sell a private key, how do I prove to you that I will not use it?
Well, you could just do it a lot. This could be your business. You have some reputation on your private key sales.
Yeah.
As an honest private key salesman.
Yeah.
No, it's well, like I always get confused because you guys have rep, and then you know there's obviously the augur rep as well, which is transferable. So okay, so now we get to this. I guess where does the shelling game come in? You know,
So when the witnesses are randomly and secretly elected because they compute their eligibility for participating in each data request locally, they run the retrieval of the data and perform the query as expected. And what they do first is to commit, to send a commitment, a cryptographic commitment of the result.
okay.
So there's a commitment and reveal scheme in there, and with the commitment is that they put the collateral, that little stake.
Commitment, is this like using zero knowledge proofs or?
No, it's using the VRF for that.
Oh, okay.
The verifiable random function. So the idea is that then at a later time they reveal the value, and everyone in the network can validate that the commitment that they published is valid for the value that they are revealing, and for their identity, of course.
Okay, and then similar to like I guess Augur or other chains, let's say there's a 60-40 split where the bad value is actually 60% because you're being attacked. Then what happens?
So the request itself is explicit on the quorum, let's say, on the percentage.
Okay, so it would also say a quorum.
Yep.
Okay, and okay, so let's say you wanted 100% for sure. Like, could you do that?
Yes.
Okay, so you
the minimum is 51%, and the maximum is 100%, obviously.
So you wanted 100, you only got it, the 60-40 split. Does it just happen again?
Then what happens is that the request will resolve to an error. So
Okay.
you always have a solution for every query, even if it's an error, and then you decide on your smart contract whether to run.
So you would actually pass this request then back to Ethereum, and they would just see, oh, it's an error.
Exactly.
Okay, and then if they wanted to, they would just ask again.
Exactly.
Okay, cool. Yeah, so no, this is similar to Teller in that way. So like theoretically, if you were trying to break Witnet, you would basically just lose money each time, and you could like stall Witnet, but it would probably be hard to break, right? Because like everybody, you would see it's an error, right?
Exactly.
Okay. Cool. Are there any like?
But then, of course, as with every proof of stake mechanism and this kind of games, let's say, a successful attacker would obviously be and go unnoticed, you know.
Right, he would be a 90% of it, and you would notice.
Exactly.
Cool. Okay, and then, I mean, the one question I had sort of in yours, because like, so you post all these prices up, and then you get 100, say 100 witnesses, is that normal number, to go grab them. You know, like if you query api.coinbase.com, and then if I query it and then you query it, literally half a second later, it's a different value. How do you sort of handle that? Like, what's a good value versus a bad value? You know, like, are you going to be slashed because of the latency?
Yeah, that's a good one. So essentially, there's filtering and aggregation happening in 2 layers. One is at the data source level. So you have multiple data sources or multiple retrieval paths, you call it, whatever. And you filter any outlier and then do an aggregation, the median, the average, the mode, whatever. And then you do the same thing for the multiple reporters. When the multiple witnesses have revealed the values, the final tally applies the same logic. That is
Okay, so you
also
would have like the
explicitly
median here,
defined
and
in
then
the
you would
regulation.
hope that you would median across all 100 as well.
Exactly. You filter any outlier and do the average or median or whatever. So how do you filter the outlier? Normally, if you have discrete data, strings, football match result,
Sure.
as you cannot have half a goal. There's no such thing. That would be discrete as well. You do median. Sorry, you do the mode. But if you're in the typical price feed use case, for example, what most of the price feeds that we have are using is a filter that removes anything that is too far off from the average, and by too far off is X times the standard deviation. So that's a filter that you can make narrower or broader, depending on whether you want to accommodate a more salient or more, like those outliers or not.
Yeah.
Like, for example, anything below 1x the standard deviation will always remove some data point.
Yeah. Yeah, no, I mean, this is cool because I mean, one of the big problems we have with people, it's like, maybe you do too. How do you get users to say, use a lot of APIs? Like, don't just grab the Coinbase price. And, you know, so you guys are like sort of explicitly doing it here, which is cool. Okay, so last question on the chain, and then I want to talk the bridge piece.
Oh yeah.
So I guess what's the 51% attack here? Or like, is there, you know, like if you bought, would the attack here be to buy 51% of the WIT tokens? Or would it be to buy, you know, like, or is it the voting share, or is it to sort of farm reputation? Is that the attack?
Yeah, the whole point with the collateralization of the data requests is that if you want to have certainty that you can have a say on the result of a specific data request, you need to have enough WIT coins in so many nodes in the which would be in a majority of nodes of the network. So you need to have a majority of nodes of the network, and you need to collateralize them. And there are simply not enough coins to collateralize them.
Okay. Well, so like it would be like,
so it's exactly what you said. You need to own more than half of the supply.
more than half the supply. Okay, no, that it's helpful because like, you know, a lot of these come down to like market cap mechanisms and things like that. Well, I mean, and then you guys have the reputation there too. Do you guys have numbers? Like, is it like how long would it take you to sort of gain half the reputation in the system? Or
That's a hard one because as I said, the reputation goes up and down very quickly. Actually, faster than we expected. Which is nice because it adds a lot of unpredictability to the system, and it makes a planned attack on reputation quite unfeasible or unpractical. But at the same time, it really limits the period for which the reputation is creating a real incentive. So we envisioned the reputation as a long-term incentive to keep being honest and not to do an exit attack or whatever. But it's not that long-term right now because the velocity of the network is quite fast. By velocity, I mean that the expiration of the reputation is not in number of blocks, but rather witnessing acts. So
Right.
how many witnessing acts? So if you have a data request that is asking 100 witnesses, that data request will signify for the network 100 witnessing acts, and that will bring everyone's reputation 100 acts closer to their expiration. So you can think like in the network there's like a reputation clock that ticks every time there's a commitment.
oh man.
So the time for expiration is denominated in that clock, which we call the alpha clock.
Oh, sorry, I just realized for those watching the video, I wasn't pinned on my video. So like it might have been really small for some people watching this at sometimes. But I just made it big now. So now you can see. Then Adan's doing an awesome job just explaining it. So like you probably don't even need my handwriting. The other cool thing I just realized about your logo is an eyeball.
Yeah.
I've literally seen your logo for like 4 years now. I just realized yesterday was an eye. So it was.
Yeah, last week some random person said the same to me. Like I have been seeing your logo for years, and I just realized that it's an eye.
Yeah. So I don't know if that's a good thing or a bad thing. It's like it's like, yeah, secretly. Okay, super cool. No, I mean the chain seems awesome. I guess, yeah, no, I mean I would have a bunch more questions on normal chain stuff, but this is, I think I understand, I guess, how the Oracle works and how the chains are.
If I had to design it from scratch again today, probably I would have gone for simpler mechanisms and for nothing that convoluted. And it's something that we are now working on. There's a lot of things that we can revisit, hopefully, and we are trying to revisit the tokenomics. We are trying to revisit a lot of stuff.
Would be a Cosmos chain.
No.
Well, I just saw the news with the DYD.
No, I mean, there's an implicit advantage in having our own chain, which is a lot of sovereignty in the way we make it work and how we can upgrade the protocol and so on with a lot of freedom.
Oh, are there a lot of do you have like chain reversions? Like could you have, like, if you got a majority of the nodes, could you have like sort of forks in the chain?
That's a good one. If you have 2/3 of the active reputation set, which are the nodes that have more power when proposing blocks, yes, you could do that.
Okay, because like that was like I thought like one attack could be like if you get all the nodes, if you get enough nodes and then you sort of like mine out, you sort of propose on your own private chain false information, and then you start reporting it to people and have them actually report good attack values back. Like that could theoretically happen, right?
Yeah. Yeah.
Okay.
Yeah. This happens only because it's those are like very hardcore assumptions of proof of stake and that kind of mechanisms.
But this is like a problem with
And,
anything bridged. I think.
Yeah.
Yeah.
So the requirement, what we have right now, it's what we call super blocks, which are convenient also for the
Yeah.
bridge and other stuff. So essentially, every 10 blocks, there's a voting for the chain tip, in which 100 nodes randomly selected again can vote on what's the chain tip, and the chain will only move forward if there's 2/3 agreement on that. So that's again quite standard, but of course it's prioritizing consistency over availability, because you are sacrificing availability there, because if someone takes 1/3 of the network, they can sort of try to deny the service of the network, like every 10 blocks roll back. The next thing is that doesn't that doesn't invalidate the transactions that existed right there. It's like they won't exist in the chain, but the transactions still are valid from the perspective of the requester. So they will struggle to find that transaction in the chain because it's not there anymore, but probably it will show up in Block Explorer and still the transaction is valid. That's a paradox there.
Cool.
Because there's a funny thing with implementing an oracle at the chain level, which is that requests are really short-lived. So you have a request posted and it will be resolved as fast as you can, and then you get the result. And when you have the result and you have taken any decision based on that result, the whole trace, there's no big point in having that on chain. And that's something that we are also like trying to reconsider. Like, what's the point of keeping the full trace of every single query that has been executed in Witnet as an oracle forever?
Right.
Probably we can drop anything that is older than
Yeah, for sure.
1 year, whatever.
Might even be pushing it, but yeah. Cool. Yeah, let's get to this bridge mechanism now, if you don't mind. Is it the
Yeah.
same on all the chains? First question.
So right now, all the chains that we're bridging with are EVM compatible chains. So yes, it's the same. We can say it's the same. The thing is that there are multiple models for the security and from the security, let's say for the security model of the bridge. Depending on what chain you are at, it makes sense to use a model or another, obviously, because for example, that there are these new chains from the exchanges that the exchanges are trying to push for, which is nice, but probably they don't have the most decentralized network of miners, and they only have like typical 21 validators, and they are all run by the same team. So if you're a smart contract developer building in that chain, probably you chose that chain for a different property that is not decentralization or trustlessness or censorship resistance. So you are probably looking for cheap transactions or whatever, and you will probably be good with a centralized model for the bridge. You don't want to pay for full on-chain validation, or maybe you are looking for a chain in which you have very little latency because you want to do GameFi stuff. Then you don't want a optimistic bridge in which you have delays, in which you need to allow the different bridge nodes to contest each other's report and so on. So it's a very nuanced thing.
No, I know. We do the same thing. You get a user and you're on Binance Smart Chain and you have 4 admin keys in your system. Like you just run your own oracle. Like you don't need us here. But yeah,
that's a good one. Yeah. So we have like the standard one, which is like let's say the less decentralized one, and at the same time we are working on multiple models that accommodate or that will work best on the different chains that we are operating on.
Yeah, because like right now, like I mean, the question I would have for here would be like, I guess these bridge nodes, are they different than the witnesses?
If it's a software that runs separately, you could
Okay.
say that it's the same, but essentially it will be 3 different Docker containers.
It might
One for the
practically be the
Witnet
same,
node,
but yeah.
one for the Ethereum node, and then you have a software that does the brokering in between.
Okay, so yeah, so you have these bridge nodes. I guess the question would be is like, how do you choose the bridge nodes, right? Because like I'm guessing you have some contract over here, and then I'm running out of ink. Yeah, who's allowed, I guess, to push into this would be, do you guys have like price feed contracts?
Yeah.
Right, and then who's allowed to push into this system, and what are sort of the rules regarding that?
So in the most decentralized mechanism, the request board contract, which is the one handling the queries and the results, that has a, let's say, a census of the bridge nodes, and uses a mechanism for eligibility that is similar to what we have inside Witnet for block mining, but in a
Oh,
simplified
it's
version.
the bridge nodes.
So
I mean,
you could say that is essentially round robin. They take turns to report.
okay, well, how were they chosen originally, or like, do they deploy their own request board? Would each user deploy their own request board? I mean, like, how would, like, so, okay, so you guys would come onto Ethereum and you deployed a request board. Who's the bridge nodes originally? You know, who are you round robining, and how did they get selected? And
Okay, like how do you populate the?
yeah, how do we
30%?
add or remove them? I guess.
Oh yeah, there's a method for that, like saying, hey, this is my identity. I want to participate in the contest.
And then I guess the foundation would probably push that on. Or
You can start with an empty set, and they can call a method on the contract to join simply.
oh, so it would be like request to join, and then the bridge nodes, the census would get to vote on whether they want to allow a new one, right? Okay, cool. Or can they vote to remove one too?
That's a good one. We don't have that right now.
Okay, yeah, no, but this was like the big one with Chainlink. I'm sure you saw it a few weeks ago, like
Yeah.
where they had like the 3 of 21 multi-sig that was just, well, I guess they were in charge of the upgradability piece. But you know, like it was like, as far as the adding nodes go, it's still like this big, like, no, it's like a black box. So, you know, curious. Okay. And then
that part we are not totally settled with, and this year is the for, let's say, for the second half of this year, and all of this is going to be our main body of work, like
yeah, no, it's
like, like reducing all the complexity and all the diversity of bridge models that we have into only 2 or 3 that we can easily reuse.
You could use Teller to bring over Witnet data. Could be. Well, since we're like the chain native Oracle, it would be like the difference. Okay, so then this would then, you would request, I guess, in the user smart contract, we'll do it over here. User smart contract, they would probably just be reading the price feed, and then
Oh yeah, it's at the end of the day, it's only a few smart contracts and a few users actually sending queries to Witnet. Normally, most of the users, they just read from the from price feeds, which is obviously free.
Well, because like that's what I was wondering, because like you would theoretically, you could like send a request here, right? And then your bridge nodes would pass it over. But like, wouldn't it be easier just to have a script off chain? Couldn't you just like go directly to the WIT chain and like send a request? And that would probably be cheaper, right? Because you don't pay gas.
Yep.
Yeah.
Exactly.
So like theoretically, you wouldn't have much people doing this, right? If they're smart.
That's something that we didn't notice in the beginning, and
Okay.
then we realized that with very little modification, you could like, let's say, override the requesting part on the Solidity side and just launch the request
Yep.
outside and have the result reported back directly. So that would be more of a pull
Yep.
workflow.
Well, it would be like pushing. It would be, yeah, it's like a weird off-chain push oracle. No, we had the same sort of thing, and like ultimately, like, yeah, like I see that happening with a lot of other things, you know, like even like with Witnet, like theoretically, like you could see a system like even with our token too, where like if they had to pay them over here for doing a fee, like you could just have like the payment over here in the Solidity smart contract, and then it like fucks with your whole tokenomics over there. And it's, you know, like similar like MEV, you could pay MEV with USDC and just wreck ETH. So
Exactly. Yeah. That's quite a pain point, let's say. Yeah, from the early beginning, we say, okay, let's do this model in which we have our own chain and we have the bridges. And then the nice thing is that the users can pay for the requests using their own native token, the token that they consider as sound money in their chain. So if you are in Ethereum, you pay for the request in Ether, because at the end of the day, most of the cost for the request is just to subsidize the gas cost of the reporter, of whoever is putting that
whoever's
final
putting that
value
here,
on chain.
yeah.
So it makes sense that you pay in it. But obviously the downside is what you said. Then your users are not exposed to your native coin of your chain. So only when you have a decentralized bridge model, let's say, in which there are multiple node operators for the bridge, then the use of the Oracle on the Ethereum side, even if they pay with ETH, will drive demand for the token on the Witnet side, because the bridge node are getting ETH and they are spending with. So they need constantly to buy wheat off the market to keep pushing requests to Witnet. That's the thing. But if you have, if the case is as in the point in which we have been for the first years, in which most of the use case are the price feeds, and the price feeds are subsidized by the Witnet Foundation, and we are relaying the requests at a loss, and we are putting the widths. We are just putting the widths from the Witnet treasury, and we are preventing the market from functioning. So we have to totally go strong on the decentralized bridge model, because that's essentially what it's going to drive the demand.
Well, I mean, that's like, yeah, that's like one of the negative things about like the market at the moment. Like everybody just uses the Chainlink price feeds because they're subsidized by Chainlink, and then all the other oracles are like, guys, like we can't pay for all your gas. So it leaves us in, it's like a weird place to be in, like, because you know eventually like you would expect that Chainlink can't subsidize it forever, but maybe they can.
Maybe they can.
Maybe they can. We'll see how much they set aside. But yeah, like as it sort of expands, like, yeah, getting people used to the idea that you have to pay for an Oracle query is like that's been a tough one for us. Yeah. Super
Yeah,
cool.
that's probably one of the biggest challenges that we are also facing with the. It's not that we need to face it immediately, but we need to have a plan for that and to come up with models that make sense for that, for the sustainability of those price feeds. Because as obviously oracles and price feeds, those are public goods in the ecosystems where they exist, and there can be an unbounded amount of contracts relying on a price feed and putting a huge stress on that. Let's say if they are protecting a lot of TVL with that price feed. So the open question with that is who pays for it.
Yeah.
do the users need to split costs? Maybe it's chain promoters, because for most chains there are the chain promoters, let's say the creators of the chain, and those have a treasury. Like, how do you make that sustainable over time?
Yeah.
And we don't have the answer right now, and obviously Chainlink doesn't have the answer either, because they are subsidizing everything. So it's a matter of looking on a case by case and seeing what makes sense. But
Well,
it's something that we need to put a lot of thought on.
yeah, I think as a space we can talk about it a lot, but like we have our first user launching with us, where Diva Protocol, shout out to them. They're doing like a prediction market thing, but they built in like from the beginning, they're like, oh, and this percentage is going to go pay the Oracle, and we're like, oh my God, like you guys, you guys thought
Nice.
about it. Great job. So like just even just getting people to think about that like is huge. So no, this is anything I missed. Like, what do we want to do next? Or like, I think we got down to the heart of it. I love the mechanism of grabbing the prices. I think, the question would be like in a way, you guys are like similar to API 3, except you don't require because like the cool thing about API 3, which I'm sure and when we're going to have them on, is like, it's like validated from the people originally, but then you guys are actually verifying the exact queries, which is really cool. Like which would be, I guess, what would be the censorship attack vector as far as like, one thing that a lot of people point out is like, how do you talk to people about best practices along how many APIs should you use? Could Coinbase censor it? Or like even around the governance of this piece, like that's something I've been thinking about. Like, because if you have even 10 APIs, that might work now, but in 5 years, they're probably all going to be different. So,
Yeah.
how do you change that and how do you put that into a system?
That's a great point. So, those are two different questions. One is on education for the users, like what the best practices, how to model their data requests in a way that they are secure enough and resilient enough. So the recommendation is to have as many data sources as possible, to pick the data sources very carefully. There are sensible numbers for the number of witnesses, for the amount of collateral, whatever. There are recommendations for that. But then, of course, there's the question on upgradability. Of course, at some point, a data request can break, can stop working, or even before it breaks, it starts to show signs of breaking in the future. What I mean is that if you have 10 data sources and you have consensus requirement of 70%, let's say, there will be a data source that will fail first and nothing will happen. There will be a second data source that will fail and nothing will happen. There will be a third data source that will fail and nothing will happen. But then when you have a fourth data source that fails, then you only get errors. So you do need to have some way to upgrade the data requests, and this is something that we leave up to the requester. So it's a smart contract that needs to adopt governance or whatever mechanism that makes sense for upgrading the data request. Right now, what we are seeing is that most of the protocols out there they have proxies that allow for upgrading their contracts, the contracts that power the protocol, so they don't have any issue in doing that. But then I can imagine that any protocol that uses a decentralized mechanism for upgrading their logic, they can upgrade the address of the Oracle, or upgrade the content of the data request, and so on, through the same mechanisms. So that shouldn't be much of a problem. Then even for the as there are small use cases in which the users maybe don't have a mechanism in place for upgrading the logic of their contracts, or they want it to be totally decentralized and written into stone, and they don't want that. What we do when we have price feeds, public price feeds in different chains, we offer two different ways to integrate. One that in which you interact directly with the price feed contract that is totally immutable, and one that you interact with it through a router, through a proxy that allows us to do hot fixes on the data requests, for example. Of course, it's up to the user to choose which one they want to use. So normally we tell them to start with the router to test it, and once they are confident enough, they can go with the interacting with the direct price feed, because that will be slightly cheaper.
Yeah,
And of
well,
course,
I mean, how would you,
totally
yeah, well, I guess
decentralized if
you'd
they are
have
going.
well, if you did that though, then the request board is only updating one of the price feeds though. Like if you ever updated which price feed you're reporting to, I guess they'd have to pay to keep it up to date from the bridge nodes. Or
Sorry, what's the question again?
then I guess whenever you're requesting data, you know, like because
Yep.
the price feed contract, like if you wanted to upgrade, let's say you wanted to change the data specs, but somebody was on that immutable one, how could they keep it running? They would have to like, I guess, pay for through the request board to keep that one going.
Uh-huh. Yeah, actually the price feeds that we operate, those are pollable, if that's a word, by
It's the
anybody.
word
So,
now, yeah.
so essentially, they have a method that triggers the update that tells the request board, "Hey, I want to be updated," and anyone can call that. So
Okay.
even if we stop support we deprecate some old price feed, anyone can keep making that updated, as long as the data request is still valid, as long as the query is still valid. If the
Okay.
case is that the query is breaking or is totally broken, then
Yeah.
it
Well, I think
will.
that was something like I want to talk with like the, you know, whenever we talk the decentralized Oracle Alliance, you know, like whenever you can think like maybe there's some way to like have off chain some sort of consensus around like, okay, what APIs consist of the canonical Bitcoin price, for instance, you know, that we can all agree on as far as like, because now like we look at like Chainlink, but like nobody knows how they pick what APIs or anything, you know, like is there a list, like it should be like the top 7 exchanges by, you know, 6-month rolling volume or something like that, and then you push it there, and then like have some sort of definition that not even on-chain definition, but that way we have like, you know,
Yeah,
that
but the nice thing is that for as long as the Witnet mainnet has been operating, you actually have a cryptographic proof that there were 100 randomly selected nodes that attested that the price of Bitcoin was exactly that.
yeah.
And it's there on chain, and yeah,
So
that's irrefutable.
all right, well, we're definitely over an hour. No, this was really good. I guess, you know, I was thinking about doing some code, but we can kind of, we don't have to get too much into the code if you just want to kind of tell people where they can go to look at your code and actually.
So from the smart contract developer perspective, the go-to place is docs.witnet.io. You have a lot of code examples, you have tutorials, you have all the API documentation, everything in there on how to get started. Normally, for a Solidity developer, if you are using Truffle, it's especially convenient because we have a Truffle box, which is like a template that has all the dependencies and everything you need to start using Witnet. That's only if you want to create your own data requests. Of course, if you just want to consume a price feed or to request randomness, there are even simpler options, and there are very simple code snippets in the documentation that you can copy and paste, and it's only installing one dependency and it works.
Nice. I feel we have not made a truffle box or teller. That's we're hard hat people, but
Oh yeah. The hard hat is super nice, and actually the
Yeah.
latest let's say proof of concepts that I built with Witnet, I did it with hard hat. Yeah,
yeah, those guys are great. They were round one Ethereum Foundation grantees with me. So like right when they started, it was like right whenever I was starting, and it was like, so we've been friends. But yeah, they're cool. Awesome. No, this has been super helpful. I'm super happy I got to learn a whole bunch about Witnet, and it sounds like you guys got a whole bunch on your roadmap as well. So I'm excited to see where it kind of goes. By the way, is it profitable to go be a miner or a validator? Is it
I
competitive?
guess so.
Right.
It's very competitive.
Yeah.
I don't know if profitable. I don't.
Ours isn't
I'm not
profitable.
that
I can
involved.
be
I'm
honest.
not that involved in mining because from the early days, we said that nobody from the Witnet Foundation would be
Oh, cool.
participating in mining or anything like that, because otherwise we would be taking block rewards that needs to be out there for the open community. But yeah, I know there are a few miners that take it very seriously, and that have really optimized hardware and software for mining the thing and so on. And it's nice actually to have the same
Do you have
same
pools in
thing
yet?
happens for you guys when you have a mining community. There's a lot of movement out there. It's like it's a nice thing to bootstrap a community,
Yeah, no, we found
because
that.
otherwise when you have a project that is simply an ERC20 and a set of contracts, it's if you don't have users in the beginning, the only community that you have is the token holders. So those are the speculators, and those will not drive usage anyway. So the nice thing of having mining, in addition to fair distribution of the token, is obviously that it creates that early community that is very techy, that creates some volume there, that also signals some market for the token, because they want to profit of their rewards and so on. It's very nice.
Cool. Yeah, no, we were launched for like 6 months. Originally, we were proof of work, and then you had like, it was like 6 months, then like people had FPGA chips, and it was like Chinese mining pools, and we're like, oh my God, like, though you had to be like way bigger. Like we were like a $4 million market cap or something at the time. It was like we're like, how is this so hard? Like, how are people so interested? But it was, you're right, it's an awesome community, so enjoy it. Anyway, thank you so much for being on, Adan. We
You're
shall
welcome.
keep up.
Thank you
And
for
yeah,
having me.
we'll
And
talk
sorry
soon.
if that was too much information.
No, definitely not. This was too, yeah, perfect. Anyway, stop recording. See you.